All right, Algebra 1. Now we're going to take a look at identifying the domain and range of certain graphs. Okay, so we're going to take you through three easy graphs so we can identify the domain and range of using that set builder notation we saw in the last video and getting through and identifying some harder ones. But we'll start with the easy ones first. So the first graph I want to take a look at is this right here. Okay, so we're going to look at, for each question, we're going to decide if it's a function, and then we're going to define the domain and range in set builder notation for this. Okay, first graph I want to look at is this one right here. Okay, more specifically, this slanted line here. We have to determine if it's a function first, and then we're going to find the domain and range. So if I throw in my vertical lines here, using the vertical line test, is it a function? Here's how we can figure that out. So once again, each vertical line represents an input. Okay, so if I have one input and it only intersects with the line once, that means there's exactly one output for it. So I have one point right here that represents one output, another point right here that represents the output for this vertical line, and then another point right here where the vertical line intersects with the slanted line, which means there's exactly one output. So once again, there's that one-to-one relationship for that. So therefore, this is a function. Okay, so I'm going to go ahead and remove my vertical lines here so it doesn't get too busy on the graph here. So in order for us to find the domain, we have to look on the x-axis. Where exactly does this line, this horizontal line, I'm sorry, the slanted line, where are all my inputs? Well, in this case, I've got an arrow going all the way to the right, which means it goes beyond the scope of the graph. And then I got another one going to the left, beyond the scope of this graph. When this happens, that means that all values of x are valid for this function, which means that using set builder notation, my domain is all real numbers. Okay. Likewise, if we try to find the range here, once again, I'm going to use green here to represent the range. Notice that the arrows still are there, which means that I'm looking at all my values below and above where the graph is. And just like we saw with the range or the domain, my range is going to be all real numbers using that script R for both of them. So my domain and range is all real numbers. This will be very important for next semester when we look at linear functions. Looking at another one, we have a horizontal line here. We're going to decide if it's a function or not. Is it a function? Looking at the vertical line test again, we see that we have exactly one output for every vertical line. One time each vertical line intersects with my line, that means this is a function. Okay, so applying the vertical line test shows that there is that one-to-one relationship again. Okay, so this is a function. I'm going to go ahead and remove it. When we find the domain, once again, we have arrows, which means that it goes beyond the scope of my graph. That means that, once again, my domain is all real numbers. But when we try to find the range, this is a little bit different because it's a horizontal line. That means there's no change in my y value. That means my range is just this singular y value that intersects with the y-axis, which is just going to be -2. So the only range value we have, no matter what x value we put in, we're only going to get -2 back as my range. Okay? Looking at another line here. This one's a little bit different. First of all, we want to determine if it's a function. So in this case, applying the vertical line, we're looking at this slanted line here. And once again, like we've seen, there is only one place where these vertical lines intersect with the graph. So it is a function. Okay? And we go ahead and remove these so we have a little bit more room. So to find the domain, we want to look at the endpoint we have, which is at -4, -1. That's important for when we figure out what our domain is. So we have an open circle, meaning we don't include that endpoint of -4, -1 in our domain and range. And because it's another arrow, that means it goes on forever to the right. So we're going to use an inequality here to represent our domain, which is all my values of x that are greater than -4. Okay? And likewise for the range. Okay? We look at this and we know that it's going to keep going on forever and up to the right. So that means for my y values, those are all my y values that are greater than -1. Okay, so once again, these are simple examples for domain and range. The next video will be on more complicated examples.